Good evening, my YouTube viewers. This particular video is going to be about the chi-square test, which is another non-parametric test. And the chi-square test analyzes categorical tables and contingency tables. And so what we're going to do is we're going to write a program in Python to demonstrate the chi-square test. But before we do that, what we have to do is we have to import the libraries that we're going to need to use to execute the program. So the first library we're going to import is NumPy as NP, which is a numerical library, but it also creates NumPy arrays. The second library that we're going to import is Pandas as PD, which is a data processing library, but it also creates data frames and series. And the third library that we're going to import is matplotlib.pyplot as PLT, which is a visualization library. And so from scipy.stats, we're going to import chi-square2 contingency. And so Scipy is Python's scientific library. Stats is the statistical module within Scipy. And chi-square2 contingency is the function that we're going to be using in this program. So what we want to do is we want to simulate the data for the contingency table. So the survey responses by gender, male and female, and product preferences A and B. So we're going to data equals NP array, brackets, square brackets, 50, 30, square brackets. So that's males preferring A, B, and then square brackets 20, 70, and so that's females preferring A, B. So now what we're going to do is we're going to convert the contingency table into a data frame. So categories equals product A and product B, groups equals male and female. The contingency table is going to be converted to a data frame equals pd.dataframe brackets data, comma, columns equals categories, comma, index equals groups. And we're going to print the contingency table. So let's come down here. So this is the contingency table that we printed. So you've got male is product A for 50 and product B for 30, and female is product A for 20 and product B for 70. So now we're going to perform the chi-square test. So chi-square, comma, P, comma, DOF, comma, expected equals chi-square contingency data. So your chi-square is like a test statistic. A P is your p-value. DOF is your degree of freedom. And expected is the expected values. So now we're going to print the test results. So we're going to print the chi-square statistic. We're going to print the p-value, the degree of freedom, and the expected frequencies. And then we're going to print the data frame. So we'll go back, look at it again. So your chi-square test statistic is 26.729. Your p-value is 0. Your degree of freedom is 1. And your expected frequencies is male product A is 32.9 and product B is 47. And your female is 37 and for product A, and product B is 50. So basically, with the p-value being 0, that indicates that the null hypothesis would be rejected. And the reason why is because it just looks, just from looking at these values, that there's a significant difference between the observed values and the expected values. So the p-value would be, the null hypothesis would be rejected. So now we're going to visualize the data. And it's going to be observed versus expected frequencies. Observed equals data dot flattened. Expected equals expected dot flattened. And so, like when you flatten data, you take it from a 2D down to a 1D. And that's basically how it works. And labels equals F, G for G, and groups for C, and categories. And so basically that's what that is that sort of like a Pythonic for loop. And X equals NP dot arrange, len labels, so that's your label locations, and width equals 0.35, and that's your bar width. So we're going to make 2 bar charts, one for the observed values and then another one for the expected values. So plt.figure brackets fig size equals 6,4 brackets plt.bar brackets x minus width divided by 2 times observed comma width comma label equals observed comma color equals blue comma alpha equals 0.7, and then plt.bar brackets x plus width divided by 2 comma expected comma width comma label equals expected comma color equals orange comma alpha equals 0.7. Okay, so now we're going to add the labels and the legends to the chart. So the title is Chi-square test observed versus expected frequencies. The X label is categories. The Y label is frequency. X ticks equals X comma labels comma rotation equals 45 comma HA equals right. You get a legend and then you get a grid, and X axis equals Y comma line style equals dash comma alpha equals 0.7. And then we're going to put some code in there to annotate the bar values, to put the values on top of the bars. And then the plt.type layout and plt.show. So you can see this is the chi-square test that we have created. So the observed is in blue and expected is in orange. And you can see that there is a significant difference between the observed and the expected. So that's why your p-value is 0. And that's why if it was a hypothesis test, the null hypothesis would be rejected. So that's it for this video. The next video, we're going to be talking about another non-parametric test, and I hope that you decide to watch it.